Hello, friends, and welcome back to the MLSecOps Podcast. I'm your MLSecOps community leader, Charlie McCarthy. And before we dive into some highlights from Season 2 in this finale episode, I just wanted to take a moment to extend my appreciation to all of our longtime listeners and our community members who have made this such a flourishing space for educational resources related to AI security. If you're brand new to the community and to the show, this is a fantastic episode to listen to. There is a clip from every single episode of our previous season, so you can go through and listen to all of our expert guests talk about the different facets of machine learning security operations, which is essentially building security into MLOps workflows through DevSecOps principles. So, if there's a particular clip that piques your interest, you can visit mlsecops.com/podcast and find the full-length episode with the transcript and links to resources mentioned in the episode. With that, I hope you enjoy the highlights from Season 2 of the MLSecOps Podcast. Cybersecurity of Tomorrow, Exploring the Future of Security and Governance for AI Systems with Martin Stanley.
So you're currently assigned at NIST to work on the Trustworthy AI project. And a part of that is the AI Risk Management Framework, or AI RMF, right? Can you talk about how those two are nested together?
Absolutely. So as I mentioned, running the R&D program, we had this long engagement with a number of partners, and that included all the work that was going on at NIST. When the AI Risk Management Framework was released earlier this year, in one of those conversations that I was having with some counterparts at NIST, really the question of how do we get the word out? How do we get stakeholders to start to engage, get us feedback on how it's working? How do we identify all the different components that we're going to need in order to make it work? At CISA, what we're interested in from a strategic technology perspective is, first of all, how can we use strategic technology in our mission? So how can we use AI in our mission space? But we also think about how our stakeholders are going to leverage AI and how that may change the attack surface we have to help them protect. And then the third area is, of course, how can adversaries leverage new technologies to malicious intents? And as a result of this, and as a result of this consistent set of engagements that we have with all of these partners, it's a real natural collaboration with NIST to help them evangelize and move the AI risk management framework out, and also provide real world feedback as to how that's going as early adopters. And then, other folks are moving in and trying to leverage the different kinds of capabilities within the AIRMF. And there's a lot of that going on right now. I can't really talk too much specifically about, particular entities that are using it, but there are a lot of federal agencies, there are a lot of large commercial companies that are taking the AIRMF and they're looking at adapting it into their risk management framework. And I think before we get too far into talking about the specifics of the AI risk management framework, we should really highlight that the AI risk management framework, just like I think MLSecOps is as well, is focused on specifically managing the risks associated with AI. There's other mechanisms and other regimes in place for managing cybersecurity and privacy and the like, and they're all related in an enterprise risk management way.
From Risk to Responsibility, Violet Teaming in AI with Alexander Titus.
I'm trying to figure out how you would guardrail against potential dual-use harm while still taking advantage of the need to kind of do maximum elements. It feels like that asymmetry is almost impossible to manage.
Yeah, that is the debate in the biotech and biosecurity world. And that's where my research is really focused on, because the concern is these large language models and other generative tools make it easier to create the scary version of a virus or something like that. But we want to be able to have tools that understand how to engineer viruses, something like a phage, while not engineering the things that you don't want them to have. And so this is a paradigm that was introduced in a really great Wired article in March called Violet Teaming that I spend a lot of my time focused and thinking on is, how do you take AI systems that you're concerned about and actually use those AI systems to try to create ways to limit the downside and misuse or unintentional applications of those AI systems? And it's not just a red team or blue team where it's purely from a technology standpoint, because if you think about it from a blue teaming standpoint, the best way to ever prevent engineering of a virus is to never do it. But the societal missed opportunity that comes with completely ignoring that whole application is hard. And so how do we actually build in responsibility, security by design? There's a whole bunch of different ways you could describe it, but how do you say, let's train AI algorithms to not identify things that are associated with transmissibility, lethality, while still identifying things that are better attacking at gram-negative or gram-positive bacteria, or whatever the goal happens to be. Because there isn't a good answer to your question, Dee. And there are people on both sides that say, let's just not do it at all, or let's not worry about it because how are we ever going to tackle this problem?
Evaluating real-world adversarial ML attack risks and effective management, robustness versus non-ML mitigations, with Drew Ferris and Edward Raff.
I think that's where in the future we might see something like there was a SolarWinds sort of supply chain attack. It wasn't a machine learning supply chain attack, but I could see that being something in the future where, especially with these large language models that are very expensive to train, like, okay, yeah, there's going to be some smaller subset of models that people are all pulling from and using. And yeah, I could see that being a valid threat model, that if someone could pull off a white box attack there, they might do it because it's actually a supply chain attack to get to everyone downstream.
Which that has a massive ROI to it, right? In that case, all of the engineering that you'd have to do, i.e. SolarWinds, to get into that supply chain and then have that massive downstream blast radius, that's far more likely than trying to detect one endpoint if it's like actually a valid input or not.
Right, like somebody, let's say, poisons Llama 2 today, like that's just going to have a catastrophic effect downstream.
Yeah. Or you think about these code generation LLMs, right? Think about poisoning these code generation LLMs to generate code that has
backdoor scripts,
exploitable vulnerabilities. Yeah.
Risk management and enhanced security practices for AI systems with Omar Khawaja.
Yeah. Over time, as I've spent more and more time with it, I've realized that in the world of AI, we have many of the same types of risks and concerns that we worried about in the deterministic world with standard static applications. It's just the words we used are totally different. So supply chain is a really good example. When we think about supply chain security in the traditional spaces, we think of it as I'm getting code from someone else. So I'm buying or I'm accessing maybe an open source library, an open source API, or I'm getting some kind of an application. I'm using it. Can I trust that application or not? So Log4j, SolarWinds, those are examples of I'm getting some code from someone else. I'm putting it into my environment, and it may have the unfortunate opportunity to cause harm. And while, yes, we can take that and apply that to the world of ML in a very simple way, we can say, I'm getting my models from somewhere else. That's true. But the other part that's also just as much about supply chain, but even for me, this was like an aha over the last few weeks, is the raw material that makes up applications is code. The raw material that you use to build a model is data. And so supply chain security and AI, it's, yes, you should care where you get the model and provenance and all that, but you also care about the data. Where are you getting the data from internal and external sources that you're using to now train the model, which essentially is to build the model. The model is literally built based on the data that you feed into it. So that data becomes of paramount importance.
Yeah, and interestingly, that's something that, as we have assets and inventories within organizations, we're used to inventorying, piece of software. Okay, maybe you model, but it's going a next step to data inventory and starting to track and audit the provenance of the data and who trained with the data, right?
You're exactly right. So, Diana, what we think of as supply chain security in the world of AI, many of us likely have heard the term training data poisoning. Training data poisoning is a supply chain security attack. In hindsight, it feels obvious, but I was hearing those terms and keeping it separate from supply chain until I finally connecting the two together. You were talking about lineage and being able to track the data. That becomes important. In many ways, it feels like the core concepts that we knew were important in our traditional world are ones that are coming up over and over again, and we're saying this is important. So just like you mentioned, having the lineage and having versioning and knowing the ownership of our applications has always been something that has been sort of the ultimate vision of asset management. And oftentimes, those types of activities were relegated to the long tail of controls that we never got to because we were prioritizing patching and authentication and logging and detection and hunting and all of those things. And asset management felt like, it's a nice to have. We know the regulators and auditors would really be happy with it. And yeah, there's some use cases where our threat team and others and our Vault team is saying it would be kind of nice to be able to connect the dots, but it almost felt like those were nice to haves. And sometimes that was out of sort of sheer practical reality, which is I only have this much time and these controls just don't fit within the time that I have. With AI, these controls around lineage and asset management and tracking and treating data as an asset, those no longer are nice to have. They become must have. So for instance, if I want to know why my model all of a sudden started to misbehave, I need to know what version of the data was it trained with. And if I just say I've got this data pipeline coming from these sources, well, that's not good enough. Well, how do I know what data came from those sources? Did it intentionally poison the training data set and cause the model to behave in ways that it wasn't supposed to? Was it unintentional? Was it a quality issue? Or maybe our suspicion is wrong and the reason the model misbehaved had nothing to do with the new training data that it got. But if we don't know what training data it got when that caused that misbehavior to happen, we don't have that lineage, that tracking, that provenance, we're in trouble.
Yeah, that's such a great point.
Secure AI implementation and governance with Nick James.
And having continuous improvement, continuous integration, following the original DevOps model with CI/CD, I think starting to include, as Protect AI espouses MLSecOps, and following that Infinity CI/CD, so that we aren't hampering innovation and we aren't hampering new releases, but also including checks along the way. I think that's the best way to go about it, because if you are inserting security reviews, impact assessments, you're doing model testing, and the like, and I believe that Protect AI, the parent company, has a number of these features. As long as you're inserting it in line, if you look at it as an assembly line, right, in like line before the shiny new thing is released, I think that's the best way to do it.
Yeah, fair enough. And like we've seen a lot of use with some of our tools, like our open source tool Model Scan, for just like one tiny attack is that you can inject malicious code in a lot of models and it runs the second the model's loaded for inference or anything. So having, tools to assess those, sign off that they're okay before they kind of exit and, go into another system. Those are, like you said, integrating like that DevOps mindset is definitely helpful.
Finding a balance, LLMs, innovation, and security with Sandy Dunn.
How do you think about an AI/ML bill of materials in terms of understanding the concepts that you just articulated? How vital do you think that is, or important that is, to begin constructing the types of things you're talking about?
I think it's nutrition labels, however we want to call them, but I think those are critical resources and tools that us as organizational leaders being able to look at those and understanding, hey, what does this system have and what do I need to know about?
RDOS vulnerability reports, security relevance versus noisy nuisance, with William Woodruff.
So where do you see these RDOS vulnerabilities? So to give you a background just real quick on the blog post we're talking about, I'm sure we'll have a link in the editing. It's talking about how RDOS vulnerabilities are not that developers should push back against all of these really low quality CVSS and CVE submissions that people will send to them. And a RDOS is a regular expression denial of service. It's taking advantage of the regex engine, because the regex engine, that's hard to say, goes both forward and backwards. So you can kind of trick it and put it in this permanent loop that ends up exhausting resources of CPU and that sort of thing. And to just get started, I'm kind of curious about what was the thing. I know you had a trigger for this blog post. I know there was somebody sent you something and you're like, that's it. I have to just go tell the entire world that this is not how this should be.
Yeah, there definitely was a trigger. The trigger, at least in my case, was I have a lot of other friends in the open source community. I often sort of get tagged on issues just to pop in and have sort of opinions on what's going on. And for a while, we were seeing like these murmurs in the JavaScript community of these reports where people would file a regular expression denial of service report and receive either CVE or some other kind of identifier. And at least in the Java ecosystem, these made a little bit of sense because it would be a service-facing thing on a website, for example, where you could hang the website. But 2 or 3 years ago, we also began to see them in the Python ecosystem, where oftentimes the domain doesn't make any sense for a user reachable input or a user controllable input. And so the one that really set me off was a friend of mine has a library, and he received a redos report that was not only in completely unreachable code, but like seemingly had never ever been used by anybody. So like not only was the code unreachable in the actual library that was reported to, but also nobody had ever called this API function anywhere ever. He did like an entire survey of GitHub's. He used GitHub's code search, couldn't find a single use of it, and so the report was like sort of doubly useless. Not only is it this sort of low value vulnerability class, but also there's absolutely no evidence that it was ever even remotely triggerable.
So we end up seeing, so we run a bug bounty program too on hunter.com, and I'm one of the triagers there. And so I do end up seeing a lot of these reports, and it feels like, and tell me if this kind of jives with your experience, it feels like a lot of people are using static analysis tools on these bug bounty programs, like Sneak. And Sneak is a fantastic SAST. Like I don't want to denigrate it at all. But it does feel like a lot of people are just using Sneak and then getting a finding and reporting like copy paste. Sneak found an XSS in this thing that's not even remotely close to an XSS. Is that like kind of what you're seeing as well? Is that, where do you think the source of these RDOS vulnerabilities are coming from? Because I don't think Burp Suite really does that often.
No, I think it's a trifecta of things. One thing is definitely detecting these kind of like pathological regular expressions is very easy statically. It is you can just sort of search through the input and find the at fault regular expression. So that's one part of it. I think another part is that as we've seen vulnerability programs classify them as a genuine attack surface or a genuine vulnerability category, the people who are like sort of scraping the bottom of the barrel for vulnerability sources latch onto that and say, oh, here's another thing that I can just sort of shove into my automated report.
Securing AI, the role of people, processes, and tools in MLSecOps, with Gary Giventhal and Caleb Walton.
So, I mean, any life cycle has a beginning and an end. It has a left and a right. So this is just more life cycle. With DevSecOps, we've been maturing this over the past 10 plus years. You got your design, your develop, your build, your test, your deploy, your manage, and you can shift left all along that. With AI and ML, you can still look at things in that same sort of a life cycle, but you have different people that you're shifting left to. So shifting left to developers is one thing. Shifting left to AI researchers and data science folks, that's different. You're shifting left into a different world than you were with developers. Similar, but different enough. Even down to basic, like one recent example, Jupyter Notebooks. That's different than a typical IDE for a software developer where they're working on their machine, writing Python or Java code or whatever and executing it. It's a little execution environment where they're doing stuff there. You got to shift left there where they're working. And even when they're working with the data. So it's still the same concept, just the execution of shifting left and the techniques you use and just where the solutions need to go. They're just more of them, and they're a little bit different.
Yeah, what about you?
I think that point about the tooling, just recently, there were some vulnerabilities discovered in MLflow, which is one of the tools, right? Like, how do folks who are data scientists do their job where they have access to some data, they can create an experiment with models and version those and tweak and do feature engineering and now test the models and see if those even perform. So like MLflow is one of those tooling frameworks, and when that has vulnerabilities, now the entire life cycle and its artifacts being the model are suspect. So that's definitely like problem number one, and it feels a lot like the early days of DevSecOps. Like we all kind of have this gut feeling that the right thing to do is to introspect more into, let's say, the third-party libraries, because we're just using them at face value. Everyone used Log4j. Why? Because it does a great job at performing the function that we needed for debugging, until all of a sudden it had this massive problem, right? And it feels like we're in that same very early days. Like everyone is doing data science, everyone is creating models or using models off the shelf, whether they come from a reputable vendor like Hugging Face or unreputable vendor from somebody just creating some model that does something clever. And it's like a little bit of that Wild West of just a lot of experimentation in work. The tools are very immature still.
AI Threat Research, Spotlight on the Hunter Community, with Dan McInerney, Marcello Salvati, and Madison Forbrick. Okay, so organizational risk that we know exists, there are a couple different pools. It sounds like there is the use of some AI-powered technologies or applications that employees might be using, has its own set of risks. And then also, if you are actually building and deploying AI, you have engineering teams, ML engineers that are creating systems. That's kind of another category. So for the organizations that are building and deploying, many of them are using open source machine learning assets, and these assets can contain vulnerabilities, right? And kind of an enter Hunter here. So if we're transitioning over to that group, what it's there for, and how it participates in this ecosystem. Who are the participants within the Hunter community, and how do they contribute to identifying vulnerabilities or bugs in AI/ML?
So I can speak to part of that. So I feel like most of our hunters are either bug bounty hunters, hackers themselves, security researchers, pen testers. We've also seen like software developers and engineers come in, hacking enthusiasts, some students that want to learn. As far as how they can contribute to identifying vulnerabilities, I'll pass it over to you two to provide more detail.
In terms of like actually, I think the biggest part about this is the scale. Like if you're able to like get 10,000 people to have eyeballs on a specific project that's open source, like you're guaranteed to like speed up the whole security lifecycle of your product almost immediately. Like it's just a scale that really helps. Like if you never had like any sort of or have any security background whatsoever, Hunter is actually really valuable in terms of finding security vulnerabilities in your open source project. Because
and it's not like we're charging for these open source projects.
Yeah, exactly.
We add these open source projects because they're open source.
Yeah,
and then we just help the maintainers find the security issues.
Evaluating RAG and the future of LLM security. Insights with Llama Index and Simon Suo.
We obviously see quite a few large corporates entering the LLM space, and you've probably seen also the report from Andreessen on the state of AI at enterprise, where you see the massive investment flowing into LLM building, like builds, right? What would you say are kind of the primary security considerations really when you think about developing applications with large language models?
Yeah, I think the way I think about a security concern is really about like the input and output of the large language model, like specifically what input it gets, right? Whether that's only the user data that's currently interacting with the large language model itself, or like you're able to surface organizational information as well, which are meant for only a subset of users to see. right? And how's the model like? How are we handling that input before that pass into the large language model, right? So I think there's a lot of things people have like thought about in terms of security concern coming from like prompt injection attacks, ability to reveal like system prompts, ability to reveal user information, organizational data. I think a lot of those make the like enterprises super, super scared. And then on the other side, right, like on the output or action it can take is pretty top of mind as well. Like a lot of these applications that are being built are Copilot or assistant applications, which have the ability to kind of do something in the real world as well, right? Not just limited to like sending an output back, right? A lot of these are being hooked up to like CRMs or like other kind of APIs so that I can trigger some change in the external environment, right? So since I'm such a stochastic system, making sure that the output doesn't have a bad consequence is like pretty top of mind as well, right?
Yeah, for sure. Yeah, we also think about it in a similar way. Obviously, input and output evaluation being the cornerstone also of LLM Guard and, in our view, LLM security. But especially as we kind of look at, expanding capabilities, i.e. connecting LLMs to, downstream systems, that expanded capability set will also lead to expanded blast radius in case of a breach. So definitely agree.
Yeah, I'm also curious. So when working on this guest post for Llama Index and integration with LM Guard, we experimented like, can you do like prompt injection, like when you ingest the data? For example, like we took 3 resumes of different people, and in one resume, like in the document, we actually put like prompt injection, which was like white color text, and in that prompt injection, we kind of asked the model to promote this person, although the person had like the least experience out of all 3 candidates. And the model actually did it. It chose that person because we kind of asked like, yeah, this person needs to pay like money. They don't have, they are really struggling. And so, yeah, like I would like to understand kind of your take and maybe some stories that you hear from the community about like, what are the specific things like with AI security, but like related to RAG?
Yeah, that's a good question. Like by the definition of RAG, right, you're giving the large language model access to a lot more data, and sometimes you don't necessarily control like exactly what goes into that, especially if it's user uploaded, right? I think the example you gave is super great. I don't know if necessarily I want to use LM to screen resumes quite yet. We actually played around with that and felt that like the potential for bias is quite high. So, but yeah, I think the general example holds, right? Like a lot of time, like these RAG applications really relying on some semantic search or hyper search to be able to surface contextual information. So I think like that part maybe is a little bit harder to game by these prompt injection attacks. But I can totally see that like even after like the relevant chunks are kind of retrieved, like sort of embedded malicious things can be passed into LM to alter the behavior, right? And like you said, like when you attach more systems, you have a higher blast radius. Another example I can think of is just like when you use these contextual information to decide an action to take, it can actually like cause even more harm in the downstream systems, right? So I think like right now, like from people who are currently building these applications, the biggest fear is not necessarily quite these kind of like harmful prompt injection attacks yet. It's more about just like data leakage, I think. Right, it's like it's not maliciously injecting some instruction to do something, but by accident, like the access control is off, and then like I don't know, like this employee gets to see the data that the CEO has put in there and that they're not supposed to see. So I think those kind of like fear and concerns are much more top of mind, at least from the conversations I've had, and a lot of that is really just about like great access control configurations as it comes to the data, like accurately propagating the ACLs coming from the data sources into the implementation as relates to like vector database or whatever search engine you have, so that like those information can be safeguarded and have the right access control.
Practical Foundations for Securing AI with Ron F. Del Rosario.
I think what's happening in the enterprise nowadays is when development teams they have an existing use case for let's say integrating an ML model in an existing product or leveraging large language models to be specific, it's usually you can classify it into two buckets. One is it's in an internally developed machine learning model, meaning your development team is responsible from zero to pushing it into production. And the second most common use case, which is prevalent right now, is like we're just gonna consume a foundational model offered by a cloud service provider, right?
Right.
So like ChatGPT 2.5.
Point to GPT or Azure GPT or AWS Bedrock or Gemini, whatever it is.
Exactly. So two different same use case for leveraging ML model in their product, but two different ways to consume machine learning models, and they have like a separate risk profile, in my opinion. Right? All right. The first scenario, it will take more time from you as a product security, as an AI ML security lead, to guide your development teams in the entire life cycle of creating the machine learning model from scratch, right? Because you tend to focus, okay, you need to try to understand a problem and how they plan to solve it with machine learning, and you try to understand how they gather their data sets for training, right? Who has access to the training data set? Where is this training data set coming from? Is it
sourced? Did I just pull it down from the open source world?
Exactly.
Did I just bring it in?
Internal trusted sources, meaning from our systems, our infrastructure. Do we have the correct proper permissions to use this if it's coming from customer data?
Controls.
Versus a training data that's being pulled externally. This is high risk. I've seen some scenarios in the past with other companies where developers started using publicly available information either from GitHub or any well-known repo out there and use that to train their ML models, right?
Yeah.
With no vetting of some sort, right? So what happened is any user with malicious intent can modify that training data originating from a third-party source. It's coming into your system, and your developers just rely on the raw output of that processing, right? Without vetting. So that's high risk.
Practical, offensive, and adversarial ML for red teams with Adrian Wood.
Yeah, so can you dive into a bit each category in your OffSecML playbook in Wiki here, just to give us an idea?
Yeah.
Yep. The adversarial category right now is primarily looking at things to do with LLMs, but I'm adding more things all the time there. And what we're talking about there is attacks against ML systems. And that category is broken down basically by the level of access that you have to perform that attack, whether that's API access or, direct model access and so on. And I've noticed that people are starting to use this in threat modeling too, this category, because a team will come to them and say, hey, we want to stick embeddings in this location for LLM RAG systems. Is that okay? And people will say sure, because they don't realize that embeddings can be fully reversed basically back to text, but with a project from a guy called Jack Morris, I believe. It's called vector text, right? So you can use the category to basically either attack something or figure out how someone could attack it for those purposes. The next category is offensive ML, which is where we're talking about using ML or leveraging ML to attack something else. So that could be, as an example, there's a great project in there, one of my favorites by Biagio Monterulli, which is a phishing web page generator. So it deploys a local phishing web page detection model and then generates HTML attributes into your phishing web page until until the phishing confidence goes close to zero, and then you use that version. And I'm getting feedback from people all over the world that are using that project that Biagio made and saying it works, it's good. I use it myself, it works, it's good. Same thing goes for droppers, using a dropper an ML-enabled dropper to make decisions about whether to drop, right? Because you don't want to drop into a sandbox. Supply chain attacks, that's got a lot of stuff in there from both of you, actually, from Protect AI.
Pat ourselves.
Yeah, there you go. So using the ML supply chain, you mentioned things before like H2O, flow, ML flow, all those things are in there, but also ways of using the models to attack ML pipelines and more, as well as data-based attacks and so on.
MLSecOps culture, considerations for AI development and security teams, with Chris Van Pelt.
Chris, as the founder, you're at a really unique intersection point that I'm fascinated with, which is, as a CISO, you obviously think about security, building security in the security program, but you're also the co-founder of an MLOps platform for AI and ML developers. So what are your points? Why do you feel it's really critical that we create MLSecOps, that we build security into the ML lifecycle?
Well, it's really aligned with our original vision for the product, right? Like, you can't have security if you don't know what the final asset is. Like in this new modeling world, ultimately, you've got a file full of weights and biases that you're going to deploy somewhere. And the default mode is like, some engineers go, they do a bunch of things, and then they produce this big file of this model, essentially, of whatever problem you're working on, and then you run it. But the only way to have any form of security is to understand how that asset was built. So to really have, in essence, like a manifest of, okay, this is the data it was trained on, this is the code that was used to train it, these are the hyperparameters that were used for this specific model. So it was natural for us to think about security, or put that as a core value prop of the product.
Exploring generative AI risk assessment and regulatory compliance with David Rosenthal.
The AI Act doesn't apply just to the people who sell in the EU. And you mentioned before Switzerland. We in Switzerland, we're not part of the EU, and the AI Act it's not Swiss law. Nevertheless, all our clients basically say that if we are subject to the AI Act, we want to comply with it. And the AI Act basically says that if you provide a product on the EU market, then you are subject to it, full stop. And if you are using it outside the EU, so a Swiss company or a US company uses a product, AI, and the output of it finds its way, intentionally, of course, to the EU, then you're also subject. So if you have an AI tool at a US company that creates customer letters, and you send that out to customers in Europe, then you are subject to the AI Act. If you care or not, that's another question. But the bigger companies, they will care.
Yeah, that's great.
And to dive just a little bit deeper, kind of jumping back to a really great question that Alex posed about these key compliance requirements for high-risk AI systems and, the consequences. Can you foresee some other challenges that organizations might face in complying with not just the EU AI Act, but AI regulations on a larger field? You've mentioned cost, and you've mentioned possibly some issues with innovations, slowing things down there, but any other challenges that you could foresee within an org, even from the board level down, when trying to kind of create their plan for how they're going to attack and comply with some of these upcoming regulations?
There are a number of issues at different levels. One, if you talk about the board level, the main issue we see there is that the board or management doesn't really understand the risks we're talking about. And then you often hear, okay, we've done a ChatGPT workshop with the management or with the board, and they know now how to do the prompts, etc. But that's not the kind of knowledge we're talking about. They, at least here in Europe, and regulated companies even more, they need to understand at these levels what is actually really the risk behind it. The security risks, the issue of how bias, other types of risks, drift risks in the models, etc., all these kind of things, they need to understand that, but there are not many people who tell them how this works. So we see actually, and it's a bit surprising, that there is not so much training at this level where board level language is used to show the people and bridge actually the gap between the techies, so to speak, and those who have to then say, okay, that's something we want to do.
And that's a wrap. Thanks again, everybody, for joining us for this Season 2 recap of the MLSecOps podcast. And stay tuned for Season 3, which will launch in September 2024. In the meantime, be sure to stay involved with the community and check out our educational resource hub at community.mlsecops.com. We also post upcoming events there, live and in person, and you can get involved with other MLSecOps community members. Thanks for being with us.